On this slide, I would like to explain what a test cross is. A test cross is when you cross an individual with an unknown genotype with one of a known genotype to determine its genotype. I don't like this definition, I have to admit. I just wrote this myself, but just reading through it, I think it's a little bit confusing. So let's look at the children to be able to say something about the parents. That is essentially maybe the simpler translation. You're crossing an individual with an unknown genotype. This would be a plant with red flowers. You don't know it. Is it homozygous or heterozygous? Both of them are red. And let's try to find that out. How can you find it out? Well, you have to cross it with a known genotype, and a plant with white flowers has a known genotype. It's a lowercase r. So an individual with an unknown genotype with one of a known to determine its. This refers to this individual over here. Okay, that is yeah. That's a little bit confusing. I would say think of a better definition here. So we have the following situation over here. Here, this is the white known genotype. We look at the plant. White flowers. We know it must be lowercase r. And what we get is interesting. We cross it with the unknown one, which is up here, and we get 50% red. So 50% of the offspring have red flowers. So let's do the cross here backwards. We have over here lowercase r from over here, lowercase r from over here, of course. All of them here have a lowercase r. And now if 50% of them are red, then there must be at least a capital R here. Well, if this is the case, then over here there must be a capital R. And if 50% are red, then the others must be white. So there must be a lowercase r here, and there must be a lowercase, the recessive allele over here as well. So if the offspring are, half of them are red and half of them are white, then you know that the genotype of this parent over here must be heterozygous. So in this case, it would be this over here. Now, if 100% of the kids, not the kids, but the flowers are red, again over here we have lowercase r's, the recessive alleles. If all of them are red, then of course you know that the parent over here must be homozygous. So again, we look at the children to make a conclusion. That's supposed to be an arrow over here. Oh, that's really bad. Okay, so what we do is we look at the children. We look at the children to make a conclusion about the parents. And essentially, our predictions are 50% red, heterozygous, or 100% red, then homozygous dominant. That is a test cross.